Hi. In this final video of this week, we're going to be looking at the marketing campaign problem. Um, this is the data for the marketing campaign problem. I've started typing the data into Excel. So let's quickly go over it. So the objective here is to maximize exposure quality, and the values are here. So I am going to do that and get the numbers in. All right. Okay. So these are my decision variables. We do the usual. Okay. So the objective function 65, 90, 40, 60, and 20. These are the exposure quality ratings, and we want to maximize that. Now, the next 5 constraints, there are the media availability constraint, how many ads you have available of each type, and you have 15, 10, 25, 4, and 30 for that. That's each of the variables individually. So it's DTVE, then ETV, then DN, then EN, then R. So each of these individually, so is less than or equal to, so I'm just going to copy less than or equal to sign over 15. So you have 15 daytime ads available, 10 evening news time ads available, evening TV ads available, 25 daytime news ads available, and 4 evening news ads available, and 30 radio ad spots available. So these are the number of ad spots that are available in each of the 5 different types of media that you're looking at. Now, the next constraint is the total budget constraint. Total budget is $30,000, and these are the restrictions that you have. So these are the costs that you have: $1,500 for a daytime TV ad, $3,000 for an evening TV ad. Then you have the newspaper ones, the 400 and the 1,000, the newspapers, and then you have the 100 for the radio ads. And this has to be less than or equal to 30,000. Right? That's the constraint, budget, total budget constraint. Now you have 3 more constraints. So we have TV, a couple of television constraints. Now, because I have written down all less than or equal to constraints right now, I am going to write the one less than or equal to constraint here first, and then write the greater than or equal to constraint next, because as you know, I like grouping constraints. So total money spent on TV ads cannot exceed $18,000. So it'll be 1,500 here, 3,000 here. Total spent on TV cannot exceed $18,000. Right? And then now we have the two greater than or equal to constraint. The first one is that the total number of television ads cannot exceed, has to be at least 10. I'm sorry, cannot be less than 10. You have to have at least 10 daytime and evening time TV ads. And then, of course, finally, the number of customers reached, we want to reach at least 50,000 customers based on the numbers that we have. So you want to reach at least 50,000 customers. So a daytime TV ad reaches 1,000 customers, evening 2,000 customers, newspaper reaches 1,500, newspaper reaches 2,500, and 300 for the radio. And this has to be at least 50,000. And these are all the constraints that we have. Yes. So these are all the constraints that we have. So once we have the constraints in, next step is to put in the formulas. Sum product formula. Now the order of the sum product formula is really not that useful. You can either say B2, B4, F4, comma, B2, F2, or you can say B2 to F2, comma, B4 to F4. Either way, you'll get the same answer. It's the same as saying 1 times 2 or 2 times 1. You'll get the same answer too. But I like writing the constraint second so that I'm consistently doing the same thing every time that I do. Okay, so I'm going to copy that. See objective function constraints. As usual, I didn't leave a line between objective function constraints. That's okay. I mean, it's a matter of stylistic preference. It has nothing to do with the problem itself. Okay. There you go. So all the data is in. Now all we have to do is solve it. I'm going to go to the solver. So the objective function is right there. That's my objective. Again, it's maximization. You want to maximize the exposure quality. And changing variable cells. Oops, I think I messed that up. So it's that. So B2 to F2, those are my decision variables. Changing variables. Of course, I have to change the GRG nonlinear to simplex LP. Don't forget that. And make sure that this box is checked for the non-negativity constraints. Now, we have a whole bunch of less than or equal to constraints. So I'm going to add them all at the same time. I'm going to go here. I'm going to click on all the less than or equal to constraints all at once. So these are all the left-hand sides. And these are all the right-hand sides of the constraint. So G5 to G11 is less than I5 to I11. So those are all my less than or equal to constraints. I'm going to click on add. And then finally, the two greater than or equal to constraints, G12 to G13 has to be greater than or equal to I12 to I13. Now I'm going to click on OK. All my data is in. It's a maximization problem. So I have that. Everything is in. I'm going to click on solve. It's going to give me the final solution. And there you go. The final solution says that so take out 10 daytime TV ads, 0 evening TV ads. So let's make sure that I have the right. So you have 10 daytime TV ads, 0 evening TV ads, 25 daily newspaper ads, and 2 weekend newspaper ads. And then finally, you have to take out 30 radio ads. These are the final number of ads that you take out of each media type. So according to this, based on this, the exposure quality, right? That's the exposure quality. That's our objective function. So the maximum exposure quality that you can have is 2370. You cannot achieve an exposure quality of more than 2370. To achieve this, you're taking out 10 daytime ads, which is less than the 15 that's available. You're not taking out any evening time ads out of the 10. You're taking out 25 newspaper ads, daytime newspaper ads, and you're taking out 2 Sunday newspaper ads, right? So that's Sunday newspaper magazine ads, the Sunday Pass. So you're taking out 2 out of the 4 available ads, and you're taking out all the radio ads that are available because they're cheap. The radio ads are only $100 as opposed to the others, which are mostly in thousands. Now you're using all the $30,000 budget that's available. Now, as far as the television budget, you didn't want to use more than $18,000. According to this problem, you'll only be using $15,000. Now you needed at least 10 television ads, and you're taking out exactly 10 television ads. And finally, you wanted to reach at least 50,000 customers. And according to this final solution, you are going to mostly reach 61,500 customers. That's your final solution.